Hello. It is, I don't know, Tuesday night. I'm recording it for Wednesday morning. This is the last page in your packet. So basically what we're going to do is a really short video from page 20. You're going to have an assignment that's kind of wrapping up the potential energy diagrams as well as page 20. Tomorrow, there will not be a video at all. It'll just be a wrap-up assignment, and it'll be due Friday. So I'm not gonna, I won't be talking to you guys Thursday or Friday. You'll just have time to work on that assignment, and that's the last assignment of the quarter. And then it'll be fourth quarter. Okay, so if you guys can take your packets out, open them up to page 20. Let me share my screen. Okay, look at how short the notes are today. Oh my goodness. Okay, so the last E word is entropy. We've talked about enthalpy already. Enthalpy is the total heat gained or lost in a reaction. Entropy is the randomness or disorder in a reaction. So let's think about solid, liquid, and gas. So these are solids. Liquids a little bit more spaced out, and gases are super spaced out. Okay, so if you had to label which and gases, if you had to label which one of these was the most random, you guys would say the gases. So solids are the least, have the lowest entropy. Whereas gases, that's a G, hard to see, gases have the most entropy or high entropy. So basically what you're going to get is like a reaction, and they're just going to say, is entropy increasing or decreasing? So is the randomness increasing or decreasing? So first thing I would do is draw a line through the arrow. You're going to look at the phase first. So we have a solid, and then we have a solid and a gas. So because you're making a solid and a gas, gases are high in entropy, it is going from an area of low entropy to high entropy. So entropy is increasing. All right. Next, we have gas, gas, and gas. Okay, so they're all gases. So what are we going to do at this point? So at this point, what you should do is count the particles. So it's also related to the number of moles. So basically, how many gases do you have? So we have 1 here plus 3. So we have 4 gases on the left, and we have 2 gases on the right. So what do you think is more random? Lower moles or higher moles? So higher moles are more random because it's like you have more things bumping into each other. So since you started out with higher number of moles and it's going to lower number of moles, entropy is decreasing. Okay. And then it's also related to temperature. So which has a higher entropy? So where are particles moving faster? A lower temperature or a higher temperature? Higher temperatures, particles are moving faster, so they're more random. Okay, so and then in general, nature prefers, and sometimes the Regents likes to ask you this question, high entropy That means lots of randomness, but low energy. So low energy, meaning an exothermic reaction. Okay, so at this point, pause your video and finish the questions on page 20. I can. Yeah, they can see you. It's fine. Okay. All right. Number one, given the reaction, as the reactants form products, what happens to the entropy? Okay. So just look at the phases first. You have solid, gas, and then solid. So gases have high entropy. So since you're getting rid of a gas and making a solid, your entropy is decreasing. Okay, which of the samples of water is accompanied by the greatest increase in entropy? So kind of like the greatest change in entropy. So the greatest increase in entropy has to occur when you have higher temperature. So I got rid of C and D. So it's either from gas at 100 degrees to gas at 200 degrees. Like if we're thinking about the heating curve, it would be here to here. Or choice A, liquid at 100 degrees to gas at 200 degrees. So letter A has the biggest leap in entropy, so the greatest increase in entropy. All right, number 3, you can ignore same conditions of temperature and pressure. What sample has particles having the lowest entropy? So solids are the lowest in entropy, so you're totally ignoring like all this stuff in front and just looking at what's in the parentheses. So C is your solid. Which sample has the greatest entropy? Greatest entropy is the gas. Since these are all gases, you're going to look at temperature. So high, oops, something here. High temperatures. So you have some in Kelvin and some in Celsius. I would just add 273 to the ones that are in Celsius. You get 298 plus 273 gives you 313. So out of those 4, B. Okay, this is which one shows an increase in entropy. So remember, solid to liquid to gas increases in entropy. Gas to solid does not. Liquid to gas does. Liquid to solid is backwards. No, no, yes. Which one has the greatest increase? This is a lot like that question. So in this one, you have 2 liquid, you get 2 gas particles plus another gas particle. So you get 3 gases. So you go 2 liquids to 3 gases. This one, you're going 2 gases to 3 gases. It has to be one that's, are you serious? I hope you didn't hear that. Okay, so it can't be one that's going down in entropy. So it has to be choice A. All right, which sample has the greatest entropy? I can't even. Okay, A, gas. Which process is accompanied by a decrease in entropy? So boiling water is liquid to gas. Condensing gas to liquid C, you need to know these phase changes. Subliming is solid to gas. Subliming is just the verb form of sublimation. Melting, solid to liquid. Okay, so you're looking for the decrease. That one increases, this increases, this increases. Letter B decreases. All right, and then which sample has the lowest entropy is your solid. So you can stop the video here if you want. I'm just going to review the potential energy diagram real quick because I feel like that's always hard at first. It's just kind of random. So if you feel fine, just stop the video, and otherwise, and then check Google Classroom for the rest of your work for today. Okay. So for those of you that want to stay real quick, just going to draw a potential energy diagram. Okay, so the main thing you need to know about these is it endo or exo? You need to know the locations of reactants, products, forward activation, energy of activation, reverse activation, and delta H for the heat of reaction. The third thing you need to know is the heat of reaction, your delta H, is equal to heat of product minus heat of reactants. So remember that delta H is heat of reaction or enthalpy, and this is just the change in heat. And the fourth thing you need to know from this graph is what happens when you add a catalyst. So I'm just going to go over those real fast, and hopefully that helps, just knowing like these main points. Okay, first of all, if the energy is starting here and going up, means energy was added, it's endo. Okay, reactants are always the first line. They could try to trick you by drawing the arrow over here, but it's still that space. So the arrow that touches the very bottom to the first line is your reactant. Product is the last line to the bottom. This is reactants. This is your product. Forward activation is the energy to the top of the hill. So from your starting point to the top of the hill, so this is forward. All right, and then reverse activation is right here. And then your delta H is always the arrow that's in the middle, that's not touching the top or the bottom. And then what happens? Oh, and then number 3, delta H is equal to products minus reactants. So anytime it mentions what is the difference of, it could be forward activation and reverse or products and reactants, the answer is always delta H. So you could also get a numerical value, like we could call this 30, we could call this 10. So products would be 30 minus 10 for a positive 20. So remember, in an endothermic reaction, you have a positive delta H. And then the last thing, what happens when a catalyst is added? Catalyst speeds up the reaction by lowering both the forward and the reverse activation energies. So that's like a little summary. The only thing that's different in terms of an exothermic reaction is it starts high and ends low, but like these are still your reactants, these are your products. In between is your delta H, and you get a negative delta H. Okay, so that's it. Hopefully that helped.